This video starts chapter 3, and in particular, we're going to talk about this whole chapter is about control statements or selective execution. Okay. So, what I mean by selective execution, typically, or so far in our programs, we've had to do sequential execution. We start at line 1, go to line 2, go to line 3. So, we get a program, here's a flow chart. It asks for X, it doubles the X by multiplying it by 2, it prints X. We can't go anywhere else. It goes through once and it's done. Okay. So with this idea of selective execution, we have where the user enters an X, enters a Y, but now we want to find out if Y is greater than X or not. Okay, which one's bigger? So we have two possible statements here. The X is bigger and the Y is bigger. Okay, only one of these will ever execute for one given go through of the program. Okay, and it turns out this program is missing something that we'll talk about when we get to the coding, in that we're not accounting for X being equal to Y. Okay. So in C++, as in Python, we're going to use an if statement for this. Okay. And the if will take a conditional. A conditional expression is one that returns a true or false. We call those Boolean expressions or relational expressions. Okay. It's going to use the following relational operators. Okay. Just like in Python, if you want to ask if something is equal, you do two equal signs. One equal sign is assignment, two equal signs is equality. Okay. We've got the not equal to with the exclamation point equal signs, greater than, less than, greater than or equal to, less than or equal to. All that's like Python. Okay. We also have the ability to create compound relational statements using the logical and the logical or. Okay, and the logical not. So and or ampersand, ampersand, and vertical bar, are binary operators. They take a left and a right. Okay. And for the and, both of the operands have to be true for the expression and to be true. So if we have X and Y, both X and Y have to be true for X and Y to be true. Okay. The or only requires one of the two to be true, but both of them could be. Okay. The not is a unary operator. It only functions on one thing. If X is true, not X is false. If X is false, not X is true. Okay. It just reverses the sign, or that reverses the value of that from true to false or false to true. Okay. So let's look at some code here to give us some examples. Okay. So I've got the basic template up here. Okay. So nothing too exciting here. Um, so let's say I'm going to start by declaring some variables. Okay, so I've got int x and y. I want to determine which of these is bigger. Okay. Now I don't have to initialize these, although I could, because I'm going to ask for the user to give us a value right away. Okay. So then I can go ahead and do, I like to put in these comment sections here just to kind of let me know what I'm doing next. So I'm going to have user enter data. Okay. So I'm going to see out, enter integer, cn x. I'm going to see out, enter another integer, cny. Okay. So I have these values. Note that we're not yet checking whether or not I actually entered integers. That's coming pretty soon. Okay. So I now want to figure out which one's bigger. Okay. So I want to determine which is bigger. Just like my other example in the flowchart, I'm going to ignore for now that they could both can be equal. Okay. So I'm going to use my if statement here. Unlike Python, the conditional has to be inside of parentheses. So if x is greater than y, that's going to return a true or a false. And unlike Python, I don't put the colon at the end. I put our brackets to hold things. I'm going to see out first number is bigger and a new line character. Okay. I can have another if here. If y is greater than x, then I can see out second number is bigger. And I should have consistent capitalization. Okay. So those are the two possibilities there, although I do need to close out that bracket. Okay. We can run this, see if it works. Looks okay so far. I can do a dot out. I can enter a 5 and a 4. First number is bigger. Okay. If I enter a 4 and a 5, second number is bigger. Seems okay. If I enter the same, it prints nothing at all. So we have an issue there. Okay. So in addition to the if only, just as in Python, we can do an else if. Okay. The else if allows us to connect together multiple possibilities. Okay. So I can make this an else if y is greater than x, print this out. Okay. And then I can end with an else. So if x is not bigger than y and y is not bigger than x, it must be true that both numbers are the same. Okay. If that doesn't seem clear, work out an example to make yourself convinced of that. Okay. So I have my first condition, if x is greater than y, this line will execute. If y is greater than x, this line will execute. If neither of these are true, so by the time we get to else, else is anything goes. Okay, let's run this, see if this works. Remember, we have to recompile every time before we run it. If I do 5, 4, first number is bigger. If I do 4, 5, second number is bigger. If I do 5, 5, both numbers are the same. Okay, so we're correct there. Okay. It's important, though, when we're looking through this and putting these together, that we realize that when we have a connected if statement, when I had the two if statements, they could both be true and both those lines could execute. If you have an if, else, only one block of code is ever going to execute. Okay. So even if something falls into more than one category, it's still only going to hit the first one and then be done. Okay. So for example, in this case, if I enter 5, 4, it's going to come to this conditional. If x is greater than y, it is. It's going to execute this line. Then it's going to skip all the way past all the other stuff and keep on moving. Okay. So let's take a look where this could cause us some potential problems if we get things wrong. Okay. So let's say we're going to ask for an age, and we'll ask the user to enter your age. Okay. Do that, get rid of all that. Okay. So for my conditional this time, I'm going to divide people into two categories, those over 30 and those over 60. Okay. So let's say in the first case, we're going to say if age is greater than 30, we're going to print out adult. I don't know. Let's 18. Let's do 18. If it's greater than 18, we'll call it an adult. Who knows what I'm doing here? This stuff doesn't matter. Okay. Else, if the age is greater than 60, we'll call them old adult. Okay. Okay. We can run this and see how it works. Pilot, run it. Let's say someone is 45. They're an adult. That's good. Let's say somebody is 77. Wait, they're still an adult. Okay. There's a problem in our code. And here's the problem. We entered 77 and it says, is age greater than 18? 77 is greater than 18. Okay. So the, we need to put the most restrictive thing first. Okay. So in this case, we would have to ask first for the age being greater than 60. Okay. Because if it's greater than 18, it's also greater than 60. So with this else if, the else if, or the if and else if, this age greater than 60 is never going to happen. Okay. Because if it's greater than 18, it's also greater than 60. Okay. Other way around. It's greater than 60, it's also greater than 18. Okay. So that's not going to work for us. Okay. Now let's close this with an example of how we can do the conditional or the complex conditionals. Okay. So in this case, let's say we want to make sure that they only enter ages between 18 and 100. Okay. So we're entering the age like before. So we want to check here to make sure that we are in range. Make sure age and range. Okay. So I'm going to say if. So two things. Age has to be greater than or equal to 18. Okay. It also has to be, so put an and, age has to be less than or equal to 100. Okay. Then I can see out that it is in range. I probably really wouldn't see that out just to prove a point. Okay. So if I enter a number, it has to be greater than or equal to 18. And so both these have to be true. It also has to be less than or equal to 100. Okay. So let's say instead we're going to, ding them if they get it wrong. So we're going to check to see if age is not in range. Okay. So in this case, we have to reverse these, right? So we're interested in age that's less than 18, or if age is greater than 100. Okay. This would be out of range. Okay. But there's a problem. I'm saying for the out of range to execute, to for that line to hit, a number has to be simultaneously less than 18. It also has to be greater than 100. No number is less than 18 and greater than 100 at the same time. Okay. So for this statement, we need not an and, but an or. This will check for those boundary conditions. Okay. And this will do what we expect it to do. So when we're doing these, again, we have to be concerned about the off by one error. So back to my first problem, we have to check not only is x greater than y and y greater than x, but also to see if they're equal. Okay, so and here as well, if we're testing our range, to go back to the other one, if I say if age is greater than 18 and age is less than 100, okay, then just see out the age, doesn't matter. Okay, then we said here they could enter 18 and they'd be okay, or they could enter 100, but both of these are excluded here. 18 is not greater than 18. 100 is not less than 100. Okay. So with the conditionals, we have to be a little bit careful on how we operate. Okay. But again, the good news is they're more or less like they are in Python. Difference being that we have to be concerned about, we got to put that in parentheses and we have to not put the colon at the end, but put the curly brackets. Okay. A couple other things that I will say, these are stylistic issues. If you only have one line in your if, it is legal in C++ to do that. Okay, just to have no brackets at all. Okay, and then if I go to something else, whatever, you notice that the cursor went all the way back over. I can see out whatever. Okay, so this line is part of the if statement. This one is not. Okay, but you can do that, but I don't like it. And I don't like it because I think it's not clear. And it's often the case you'll go back and add more things in here and you'll have to add the brackets anyway. So I like to make it very clear. Okay. from this starting bracket to that starting bracket. And if you notice, if you can catch that or not, but if you watch, when I enter this ending bracket, the bracket above it, this bracket right here, is going to light up briefly. So I know what I'm connecting to. If I go one more time, it goes all the way back up to there. Okay. I go one more time, it can't find anything. Okay. So that's a way to keep track of what you're doing. It also is going to indent things for you automatically. If it doesn't, something's wrong. Okay. The other thing people do with if statements, which I don't like, is this. Okay. That's kind of a Java thing, I think. You'll see that in a lot of code. And it does save one line, but to me, it doesn't have the symmetry or the flow, and I find it harder to read. I find that much more readable. Okay. So that's our first type of conditional statement. We have the if, we have the else if, okay, we have the else. You don't need an else if. You could just do an if and an else if you want. Okay. And you can have as many else ifs as you want till you run out of space on the computer. Okay. So in the next video, in part two, we're going to talk about the switch statement, which is a different kind of conditional.